All right. So, hey guys, my name is Jessica, and I'm a senior CS major from University of Maryland, College Park. Today, we're just going to be talking about Booleans and Boolean expressions and things like if statements. So, first, we'll just be going over what's a Boolean, any operators that you have to use with Booleans, and any operations that deal with that can return like a true or false. Next, we'll be talking about things like if-else statements, else-if, switch statements. These are just conditionals that you can use with Booleans. And then um, I'll give you like resources. And if you want to, we can go over a workshop. Otherwise, we can just ask questions, or I'll try to give you guys trick questions or something like that. Um, Again, if you guys have any questions, feel free to just either interrupt me and unmute if you're comfortable, or just drop a question in chat and I'll try to answer as quickly as possible. If you guys feel free to let me know if you want me to go over a slide or to slow down or speed up, anything like that. All right. So first off, I'm just going to go over what is a Boolean. A Boolean is basically a data type. If you remember the primitive types we went over for the second lesson, this was one of the types of variables we covered. It only holds two values, true or false. And just like any other non-constant variable, its value can change depending on its value can basically change during the course of your code and basically just reflect the change in the condition. So basically, it's just a variable that can hold a true or false value. These are just two examples of Booleans. So one is light on, which can be true, or cloudy, which is false. So first, I'm just going to go over Boolean operators. So these are operations you can do on a Boolean. The first one is this exclamation point, which means not. Two ands mean and then these two straight lines, they're called pipes. This means or. These are just like little operations you'll have to memorize with a Boolean. Any questions about these? Sweet. So I'm just going to show you guys a demo using these three operators. I'm going to see if I can share it. And I'll just drop the link in chat. So basically, this is just a demo showing you guys how these operations work. So I have this program where A equals true and B equals false. And basically, if I do A or B, this should print true because A is true, and even though B is false. Something else is A and B, which will print false because B is false. And then finally, not B, which would be true. Do you guys kind of get how this works? So basically, or is if both statements are false, then or will be false. But if one or the other statement is true, then it will be true. And is they have to be both true to be true. If one of the statements is false, then it'll return false completely. And then finally, not is just the opposite. So if we run this, this should print true, false, then true. And then just something to note. So basically, a fun fact is that computers are very lazy. They want to do the least work possible. So basically, how something like an or statement can work is if A is true, then the statement is just confirmed true, right? I don't even have to check if the second statement is true. So if A is true, then Java will basically exit this statement and be like, this statement is true. But if this is false, then I'll have to check the second statement. For another example is if A is false over here, then the rest of the statement, no matter like what the rest of the statement is, this and expression is just completely false. So if A is false, then B will not be checked. So B just, basically Java just won't even compute B. So, but if like A is true, then Java will have to check if B is false. So this can be really helpful if you want to do like little tricky, basically do some tricky programming in Java. Just remember that computers are lazy, and for OR statements, if the first statement is true, the second statement won't be checked. And for AND statements, if the first statement is false, the second one won't be checked. Any questions about this? All right, sweet. So next, I'm just going to talk about operators that don't necessarily involve Booleans, but return a Boolean. So things like if you're checking an equals, like if two variables are equal to each other, you can't, how do I put this? These don't necessarily involve Booleans. Like you can check if 1 equals 2, but 1 and 2 aren't Boolean types. But it will return a Boolean, so a true or false. So the first one is we have this double equals, and this compares physical equality. So do the two variables hold the same value in memory? And then the second one is a dot equals, so an equals method. And this compares content equality. So are the contents of these two variables the same? Then we have like greater than, less than, greater than or equal to, less than or equal to. I think these last four are self-explanatory. But to go further into the double equals versus dot equals, double equals compares if these variables hold the same value in memory, and dot equals compares the content. So if you remember in last lesson when we talked about reference types are actually variables that hold addresses, right? They basically point to the object instead of containing the value of the object. So when you have something like that, basically your like the physical memory and content and whatever content that your object has can be different, right? So you can have two strings that both have like A, B, C, D, but they can be in different places in memory. So that's why we have this equals equals, but a dot equals method. So I think this might be better explained if I show you the demo. So if I have something like, if I create two strings and they're both called hi. So if I have like this one string will be in one place in memory, and then two string will be in a different place in memory. So if I compare one string equals two string, these two variables are pointing to different places in memory. So this would return false because they're technically not the same object, right? However, if I do one string that equals two string, this would return true because the content of these two strings are the same. All right. And we can also just look at examples of the other operators. So actually, let me just. So the other examples are just like if you have integer a equals 10, b equals 7. If you do like a equals a double equals b plus 3, then this will return true because 10 equals 7 plus 10, or 7 plus 3. Same idea for this. So like, is a less than 10? Is 10 less than 10? Not really. So it'll return false. But if I do like, is a less than or equals to 10? You kind of get the idea that like these are basically the same idea as like in math, basically. Oh yeah, something else about the dot equals. something else to note about the dot equals method is that all objects have this dot equals method. And the general rule is, unless you're actually checking that like the physical equality, like are these two objects exactly the same object in like the physical memory space, then like you should generally always use the dot equals method. Um, we also have some, we also can do like different, we can also use these same operators with like other primitives. So like you have chart A or symbol 1 equals A, symbol 2 equals B. We can also do like is symbol 1 less than or equals to symbol 2. So why would you think this would print true? So how can we basically tell if this character A is less than B? The general idea is just that like we talked about in the primitives lecture, you can basically convert any symbol like A, B, C, D. Yeah, exactly. So according to the ASCII table, yeah, according to the ASCII table, um, these characters can be converted into numbers. So I think A is like 63 or something, and then B is 64. So that's why symbol 1 is less than symbol 2. And then same idea for this. So this would print false because 63 is not greater or equal to 64. 64, yeah. However, like if you try to use like this less than or equals to with like Booleans, that wouldn't work because Java will basically be like, you can't use this on a Boolean. It would just throw a compiler error. So just be aware of that. Like even though you can convert characters into numbers, you can't really do the same thing with Booleans. Any questions about this? All right. So next, we're just going to talk about basically if conditionals, basically. So things like if statements, if, else if, and then these fancy things called switch statements. So the first one is just if else statements. These are the most basic form of conditionals. So like if this is true, then we do this action, else we do another action. The else is completely optional. You can just have one if statement. Else is just for like if you want to do something different, if the statement isn't true. So yeah, this is basically like you would just type it like this. So like if parentheses Boolean statement, make sure you have these curly brackets, and then else curly brackets other action. All right, so I'm just gonna go through a basic demo. So let me share the code first, and then we can talk about what's happening with this. So basically, in this example code, I have basically a scanner that takes in user input, and then we have this Boolean called is hungry. Once the user types in like a yes or a no, after so like first we'll ask like, are you hungry? If the user types in yes or no, it'll basically put the statement into is hungry. So we'll basically check against like if user input equals yes, then is hungry will be true. So if the user is hungry, we'll just say let's eat pizza, and that otherwise we'll just print out like go play Animal Crossing. So basically, if you someone's already running this, but hopefully it's not a teacher. So basically, we have this program that prints "Are you hungry?" If we type in yes. Seems like we have a bug. So why do you think this code wouldn't be working then? if we're checking while is user input equals no or yes. So right now, like our code, if I type in like this, it'll always type in that. So let's basically look at this loop and see what's up. So basically the idea for this loop is that while the user hasn't typed in no or yes in all caps, we'll basically continue printing this until they type in one of these strings. However, if I type in like yes, even if I type in capital yes, it won't work. And the idea is basically like, again, we can't have this doubles equals in this as a content equality check. So basically, let me just fork this because I think another teacher is using it. Yeah, there's a function to turn all the user input to all caps. So over here, I've actually put a line that's like user input that to uppercase. So that basically will, if I just type in like lowercase yes, it will turn everything into all caps, and then it should check against this. However, for some reason, it isn't doing that. And let me just fork this so I won't mess up the other teacher's code. But there's an issue basically in this conditional check where for some reason, this will always return false. Is it because of the not? Not exactly. So the idea with this loop is while the user hasn't typed in no or yes, then it'll ask, are you hungry? And it'll like take in the user input. So the like in basic English terms, it's like while the user input is not valid, I'll continue printing this prompt. Put the dot equals method instead of equals equals. Exactly. So what's happening right here is Java's like, is this user input exactly this no string or exactly this yes string? So like, is like, as in they're literally the same object. However, if I like scan this line, they aren't exactly the same object. They're the same string. Like they're the same, it's the same word, it's not the same object, basically. So that's why it's always returning, like this is always returning like invalid input, basically. So if I actually change this to like user input dot equals, and then if I change these all to dot equals methods instead of the double equals, then this should run correctly. So I should be able to even type in like a lowercase yes, and it'll say let's eat pizza. Or if I'm not hungry, I can type in like lowercase no and go play Animal Crossing. But if I type in something like ABC, it'll like continue asking until I say yes or no. So that's the general gist. And I'm actually gonna share this corrected code just so you guys have reference to like what's the actual working code instead of the buggy one. So that's the basic idea of like this if else. So like if this like Boolean statement in here is true, it'll run like whatever code that is in this code block. Otherwise, else it'll run whatever is in here. And then we've also got a sneak peek on like looping and all that. So any questions about the code we just looked at? Sweet. So next, I'm going to talk about we've called it else if statements, but it's actually if else if. So this is basically if you want to like check multiple conditions, or not exactly check multiple conditions, but like if this is true, then do this. Otherwise, if this other thing is true, then do this other thing, and then else whatever. So basically, it's kind of like if I want to, if I want to sort of check against a bunch of different stuff. Like if I want to, if like, if, or maybe I can just use examples. So like if I'm hungry, then I'll eat pizza. Otherwise, if I'm tired, then I'll take a nap. Um, if if both of these aren't true, then I'll go play Animal Crossing. So that's the general idea of if else if statements. I kind of say else if is inaccurate because you have to have that first if statement in order to have an else if statement. And you can chain like a bunch of else if statements together. So like if I'm tired or if I'm hungry, I'll eat pizza. Else, if I'm tired, I'll take a nap. Else, if I'm bored, I'll play a game. Else, I'll go outside or something like that. So you can have as many else if statements, and then even then like this again this final else statement is optional. So it can be like if this is true, then this. Else, if this other thing is true, then this, and it can just stop right there. So I'll just show you guys this demo. It's a little hard to click with the Google Slides thing getting in the way. So again, this is the same code from the first demo, but I've sort of built something extra on it. So again, we have this while statement like that will ask like, if you're hungry, are you hungry? And then if you type in no or yes, it'll store everything in is hungry. But I've added this extra layer. So we have yet another Boolean that is tired. And it'll do the same thing. It'll keep on asking, are you tired? Until you type in no or yes. And then it'll basically store that in is tired. So if you type yes, then it'll store true. If you type no, it'll store false. And then we also finally have this if else if statement. So if you're hungry, we'll reply like, let's eat pizza. Else, if you're tired, then it'll just print sleep. And then finally, if you're not either of those, it'll type go play Animal Crossing. So we can first try running this. So first, are you hungry? Let's say no. Are you tired? Yes. And it'll just type in sleep. Just be aware that these else if statements, I want to say they're kind of independent, or not independent, they're dependent on each other. So basically, if I run this again and I say like, hopefully this will come out. Basically, if I type in yes for is hungry and no for is tired, it'll go into this block. So like the first if block, because is hungry is true. It'll print out like let's eat pizza, and then it'll exit the program. So it won't be able to like run any of the code after this that are in like different else statements. So are you hungry? Yes. Tired? No. And it won't run anything else. Even if I do something like if I type in yes for both is hungry and is tired, it'll only run this first if statement because basically it'll just enter this block and then it'll exit this entire if else if chain basically. So if you want something to basically run no matter what, you'll have to put it outside of the if else chain. Any questions about this code? I would highly recommend that, like, after, like, on your own time, just like go into all of these demos and sort of like pick them apart. If you have any questions, like outside like outside of class time, feel free to like ask in the Girls Code It Discord, or I think you can like contact us through our website. But this is basically in general how if else and if else if statements work. So if no one has any questions, we'll just move on to our final like conditional statement. So the last one we're going to talk about is switch statements. And switch statements, I would say they're fancier if else if statements, but they're like 10 times more readable. So basically they're a giant like if else if chain that can only check a single value. So like I put this, like if you were trying to like roll a dice or something and you wanted to like do something different for each value of the dice, it would be really messy and really unreadable to like have like if die value equals 1, like do this, else if a equals 6, do that. A easier way would just to put it all in a switch statement to make it more readable. And the basic anatomy of a switch statement is you have this switch keyword, and then in parentheses you'll have whatever like value you're checking. So like if I have a string, I'll put it like in here. If I'm checking against like the numbers on a die, then I'll put like a die value in this parentheses, and then I'll have like these curly braces. Then inside the curly brackets, I'll have my first line will be like case, and then whatever value that I'm checking against. So like if I'm like in this ice cream example, if I'm checking if ice cream is equal to chocolate, then my first case could be chocolate. And then I have the colons, and then inside I'll have like, I'll do whatever I want, basically. This is like sort of the inside of my if statement. And make sure, generally you'll have like a break statement, which will break you out of the switch statement. We'll explain why you would need that later, but just make sure in general, make sure you put a break at the end of your cases, and then I'll have my second case and my third case and however many cases I want. I think like this is the general anatomy, like how you would write a switch statement. And then I'll show you an example just so it's a little more clear. This is just another example of like if I'm checking against a month, then I can have like I'll put month in the parentheses. I'll like I case 1, 2, 3, 4 because month is an integer. And then I'll just move on to the demo. Any questions about like what I've talked about so far? All right, so I know like switch statements can be a little weird because they don't really translate into English, like if, else if, and stuff like that. So maybe it'll be better explained in this demo, like why you want to use a switch statement and how you can use a switch statement. So in this demo, we basically have a random number generator that will pick between random integers 1 through 6. And then we have a scanner. The scanner is kind of my cheesy method of just rolling a die, basically. So basically how this program will run is, let's say you're in a D&D campaign and we have this like situation where your character is like stuck in the woods at night and you have to like roll 1 through 6 for like what's the outcome. So let's say, I think it's still compiling. So basically it will just print out like your character is stuck in the woods at night. Press enter to find out what happens. This is secretly a scan next line, which is just like you're rolling your die. It will generate the RNG will basically generate an integer 1 through 6, and then depending on like what die value you roll, a random event will occur. So like you get attacked by a bear, or like nothing happens, or you find a nice cabin in the woods. So each time I run this should be random. And the general idea is like for each number on the die, I basically want a unique situation to happen. But like you can't really tell from this, right? Because it's so messy. So I have like if die row equals 1, else if die row equals 2, else if, else if, else if. This is basically pretty unreadable. If you look at this at first, it's hard to really tell like what exactly this code is doing. So a better way to do this, if I comment all of this out, or I will actually fork this first. So a better way to do this is if I put everything into a switch statement. So I happen to have a really nicely written switch statement right under my giant if-else if chain. So if you look at this first if-else if statement, it's kind of just hard to tell like what exactly this does. First off, this is just like a lot of words. It's a giant block of text. I don't know exactly what's happening in here. However, if I compare that to like a switch statement, this is like 10 times more readable. So basically this statement is saying like, hey, I'm gonna check my a bunch of cases against this one variable die row. And these are the 6 cases that can happen. So case 1, like if die row equals 1, you get attacked by an armed bear. If the row equals 2, you get attacked by an unarmed bear. So, and then all of these different cases all the way down to case 6. So notice that for each case, I put a break statement, and I have the case keyword, the semicolon, do whatever I want in here, and then the break statement. So this is just generally how you write a switch statement. So if I comment this ugly if-else if statement out, this will basically run the same, but this is just generally more readable. So what the PowerPoint didn't talk about, but I kind of want to note, is just that there's a special case called a default case. And that's kind of like the else at the very end of your if-else if statement. So this is what happens if, like, say I happen to roll a 7 on the die or something like that. It will basically check against like, oh, this die isn't equal to 1, 2, 3, 4, 5, or 6. So I'll just refer to a default case and print out the end. Technically, like, the code won't be able to reach the statement, but this is there just in case. So let's go back to when I said you technically don't, when I said like break is kind of an interesting case. So when I said you need the break keyword at the end of each case, I kind of lied. So basically, the reason you want to have a break keyword at the end of each case statement is that it breaks you out of the switch statement. So if I don't have this break, so let's say I comment all my breaks out over here. just choose my changes. And hopefully that doesn't break any code. So let's say I comment all my breaks out of this case. This will actually compile. Java actually has no problem if you don't put break at the end of your case. However, let's see what happens once I click enter. So you'll see that I've happened to wrote kind of the worst case for this example, but basically I wrote a 6. However, I've also printed, instead of like just printing this, like the code or the sentence that was meant for case 6, I've also printed the default, which is technically unreachable code or unreachable code. So basically what this break does is, like I said, it'll break you out the switch statement. And what I meant by that, it'll exit the switch statement instead of running all the rest of the code. So what happened was Java went through the switch statement. It was like, all right, die row equals 6. So I'll just hop to case 6. I'll run this, and then I'll run all the code that's under 6. So let me run this again, and hopefully I'll get like a better example. There we go. So in this case, I wrote a 1. You got attacked by, or I wrote a 2. You get attacked by an unarmed bear. So what Java did is, over here, it was like, all right, die row equals 2. So I'll go to this case 2, and I'll run the code all the code that's after 2. But because basically I didn't add the break, it didn't exit the switch statement when I reached the end of the case. So it just ran everything under it. That's kind of the difference between a switch and an if else, is if you don't add the break, it can run code that's in different cases, basically. Any questions about this? So you can change the case number to an alphabet or a string. Yeah, so anything that you can compare, basically. This switch statement, like die row only happens to be an integer. It could be like a character, it could be a string, any like basic like primitive type or string. So yeah, it could be a letter, it could be a string. The only thing it can't do is it can't be like, I can't have a case of if die row. I can't do a thing where it's like die row less than or equal to 4. So this is invalid in Java. Switch statements aren't just a Java thing. So like there are languages that support switch statements that can be like if die row less than or equal to 5, or if die row is greater, or even like die row greater or equal to 2, less than or equal to 5. This is invalid for Java, but can be valid for other languages. But Java will basically only support like strict equality. So like case 1, or like case hello world, or things like case A. So only if the variable is equal to the case value. Just a reminder, for like all of your demo code, just make sure you fork by pressing like up here, these 3 dots, and then fork before like you change your code, just so not like when you change stuff, other people won't be affected by the changes. All right, so let's actually do this quiz then. So first, number 1, what does this if statement mean? Let's do this first example together. So yeah, so basically the translation of number 1 is if x is equal to 72. So that's correct. All right, so let's do number 2 then. What does this statement mean? Correct. So the statement means if x is less than 20 and x is greater than 40. So let's say in this case for number 2, x is 13. Will this second statement run? Yeah, so 13 is greater than 40 would be false, but it would still run. So basically what I mean is, let's say in number 2, x was 13. So I'll actually just type out the code in my notes. So let's say here. If for number 2 I had code like int x equals 13, and then in some other part of the code I had like if x less than 20 and then so basically once I get to this if statement, Java will first check like if it'll first evaluate this first expression. So x less than 20, and then it'll return true because 13 is less than 20. Once it returns true, basically, like I said before, computers are very lazy. So they want to do the least work possible. However, in this case, if this was true, there's still a possibility that this second statement is false and this entire true and statement will be false. So it'll run this, it'll see that's true, and then it'll go to the second statement and it'll have to check if x is greater than 40. So is 13 greater than 40? No. So the entire statement will return false. However, if over here I said x is, let's say x equals 30. So if I hit this if statement, 30 is less than 20. So this will return false. Because Java computers are just lazy, basically what happened is if this first statement is false, no matter what this second statement is, if it's true, if it's false, even if it returns a runtime error, this entire statement will be false no matter what. So there's no point in really evaluating the second statement. So what happens is Java will actually just skip the second statement. It won't even evaluate this expression basically, and it'll just skip this entire, it'll just say this and statement is entirely false. It doesn't matter what the second statement is. This entire statement is still false no matter what. Is that does that clear it up? So when is the second statement used? The second statement is only used when basically this first statement is true. So basically, let's say I have x equals 30 here, but somewhere in my code, x will be equal to 10, and then more. So let's say somewhere along the way, x gets it gets reassigned a value, and the value is 10. Then over here, Java will be all right, is 10 less than 20? That's true. Then it will have to evaluate this second statement. Is that a little clear? So basically for and statements, if this first statement is false, no matter what the second statement is, it will return true despite the second part. Not exactly. So for and statements, remember that for the double and, it has to be that the first statement is true and so is the second statement. Or is where so Yeah, so basically for and statements, both the first part and the second part both have to be true. So that's why if this first part is true, then the second part matters. For x equals 10, so technically, like for this entire statement, this will return false because 10 is not greater than 40. However, what happens is that it'll first evaluate this first statement. Yep. Yeah, so I'm just saying like for strictly this part, it will be true. So strictly speaking, 10 is less than 20. So that's why Java has to go through and it has to check the statement. This is very important if let's say, because once you get into more complicated code, it won't just be like, oh, is 10 less than 20? Or, oh, is this number less than or equal to this number? These can be super complicated, these can be super complicated expressions once you get into like more complex code. So what can happen is like, let's say I have code over here that like returns a runtime error. So I have some invalid code. And let's say like whenever this invalid code runs, it'll just return a runtime error. What can happen is you can have hidden bugs that will basically be like, let me delete this part. That'll basically be like, if I, what will happen, like in this case, is X, or Java will be like, oh, so 30 is less than 20, or it's not less than 20. So this entire and statement is false, and you'll just miss this bug over here. So that's like why I want you guys to sort of keep this in mind, because once you get into more complex coding, these little bugs can happen just because Java and other languages evaluate Boolean expressions in very hacky ways, basically. And then again, there's a same sort of treatment with or statements. So like if x or x greater than 40. So similar thing, kind of. So in the case of or, only one of these expressions has to be true for the entire or statement to be true, right? So if this ends up being true, so if, and then if this evaluates as true, Java will again do shortcuts, and they won't evaluate the second expression. So just remember, for and statements, if the first statement is false, then Java won't evaluate the second statement. And for or statements, if the first statement is true, then Java won't evaluate the second statement. And this goes across multiple languages. So Python will do the same thing. Basically, all languages will treat ands and ors the same way as Java does in these cases. Any other questions about this, or like anything else in the lesson? All right. So I saw that some people wanted to do the workshop. So let me see if I can actually share this. Okay. I'm gonna copy this link, and hopefully, there we go. So here's a link to the workshop. Again, remember to fork before you edit the REPL. Basically, the idea is we're trying to check if you remember the lesson from last week. So like, review how do you create a scanner? How, like, which library do you have to import to be able to make a scanner object? And then how can you store a string, something like that. And then basically this program is just like a basic program of, we want to be able to take in, say, like an ice cream flavor. And then in the end, we want to check if this ice cream flavor is in like specific stores. So we have like these two strings called flavors that you can initialize to whatever flavor you want. And then you have to find some way to basically take in like your friend's favorite ice cream flavor and then check against these two flavors from two different stores. And then we'll finally like just print out something. That's like based off of if your ice cream is in like store 1 or store 2, or if it's not in any stores. So right now, I think it's 3:04 Pacific Standard Time.